All right, this is question number 2 from exercise 8L, and they want us to find the MacLaurin series for that by using an identity. Okay, so in order to do this, let's just find this MacLaurin series. So I'm just going to go through and I'm going to evaluate it as I would for a MacLaurin series. So 1/2 minus cosine of 2x over 2. Well, if I substitute 0 in, I get 0. So the first step of my MacLaurin series is going to be 0. Right. So now let me take the derivative of that. So d dx of 1/2 minus cosine 2x all over 2. Well, that zeroes out. That would turn into negative sine 2x all over 2, and then times 2 because of chain rule, and I'd be left with just the sine of 2x. When I evaluate that first derivative at 0, I get 0. So second term is 0, and I guess let's do that officially. Let's do 0 over 1 factorial x, right? And the next one's going to be over 2 factorial x squared. I guess I can just fill this out a bit. Over 3 factorial x cubed, then over 4 factorial x to the 4th, and then over 5 factorial x to the 5th, and then over 6 factorial. I should have enough information by the time I get to here that I can write down the series in sigma. All right, so let's do our next derivative. So d dx of sine 2x is going to be 2 cosine 2x. And if I evaluate that second derivative at 0, I would get 2. I would just get 2. All right, so 2 is what is over there. Let's keep going. So that value was 2 cosine 2x, so I need to do d dx of 2 cosine 2x. That is going to be negative 4 sine 2x. So that derivative is my third at 0 is 0. I now need to do d dx of negative 4 sine 2x. That's going to be negative 8 cosine 2x. Yep. So I get a negative 8 here. Right. When I evaluate, sorry. Cool. Next one, if I do d dx of negative 8 cosine 2x, I would end up with 16 sine 2x, right? And evaluating that 1, 3, 4, 5 at 0 would give me 0. And the last iteration I need to do, I guess let me get that 0 in. Have 0 here. Oh, did I skip one? 1, 2, 3, 4. So, sorry. What's going on here? All right, first, second, third was 0. That's where my issue is. That's supposed to be a 0. Okay, so I've got 0, I've got negative 8 here. The 5th was 0 again. We just got to do the 6th now. Sorry. That would be d dx of 16 sine x. That's going to be 32 cosine of x. of 2x, sorry, of 2x, and that's just going to give me 32 when evaluated. All right, I should have enough information here to do this. So right away, this one stays, and it's just x squared. This one, so negative 8 divided by 4 times 3 times 2 times 1. So that just turns into minus 1/3 x to the 4th. This here turns to 6 times 5 times 4 times 3 times 2. And the 32 on top. Those go. I'm left with 4. That turns to 3. That goes to 2. So 3 times 3 times 5 is 45. I think this was... Okay. All right. So we know that this is what that sequence is going to look like, or that series is going to look like. So now what we have to do is we need to figure out how we can write this as a sequence. So right away, my first term is actually, so that's when n is going to be 1, because it's my first term of this series. It's the only one that actually shows up. So if I want to write this as a series, then if my first term is that, then in order to get that squared, x has to be raised to the 2n power, because that would give me that squaring that I'm after. Additionally, because we are, and it's positive, got it. My second term is when n is 2, just checking, does that still work? Well, x to the 4th, 2 times 2 is 4, so yeah, that'll work. So we know that 2n has to work. This also gives us a little bit of a hint of what's going on here. Notice it was negative, it was positive here, and then it's positive. So that means that there has to be a negative 1 here somewhere. That has to exist. And in order to counteract that negative 1, well, if we just raised it to the first power in this occasion, that first power that would mean that our first term is negative, but it's not negative, it's positive. So I have to be raising this to the n something, and I need it to be negative. So if I do n plus 1, that'd make it so that my second term is negative, my first term is positive. I'm pretty good with that. We are always going to the power and the factorial have to match each other. So we would be 2n and then factorial. Now, right here, we have to deal with something, because this would actually turn into, this would turn into 1 over 2 factorial x squared. Well, that doesn't match. That needs to look like that, just x squared. So there's a hint here. What would I have to get rid of this 2 factorial on the bottom? I actually have to have negative 1, n plus 1, and now I have to have 2 involved in some way, so it would cancel out. And then we'd have x squared. Now if I look at my next term, I need this to be 1/3, what is this? 1/3 x to the 4th. That's what it's got to look like. So we've got the negative 1, but now it would be over 4 factorial, and then x to the 4th. So we know there's a 2 involved. So let's just figure out 2 is going to be raised to some power, and 4 times 3 times 2 times 1. Well, this 2 is going to cancel there, and I'd be left with 12 on the bottom, right? Yeah, I'd be left with 12 on the bottom. So somehow I have to find a way of, I need this, I need a 4 on the top. Well, what power do I have to raise 2 to make it equal to 4? So -1 times 2 squared all over 4 factorial x cubed to the 4th, that gives me that. I would have my 3 on the bottom, I would end up with that value. But I'm dealing with a 4th power here. So I need some way of taking power and making it 2 using my n's. So that'd be 2, 2n minus 1. Yeah, that's 3, because I need it to the 3rd power, because I need that to be 8. So 2, and that would be n, 2n minus 1 would give me. So that would mean that my thing is going from k equals 0 all the way to infinity. Actually, I'm starting with k equals 1. No, k equals 0. That's fine. And I need this to be -1 to the n plus 1 times 2 to the 2n minus 1 all over 2n factorial, and then this is x to the 2n. And that will give me each one of these steps. We're just going to check it to make sure that it works for this value right here. Okay? I screwed that up. That's a 6 there. All right, so let's just see if it works. So if I did -1 to the, this is my 3rd term, so 3 plus 1, times 2 to the 2 times 3 minus 1, all over 2 times 3 factorial, and then this is x to the 2 times 3. Well, we know that the x to the 6th works. -1 to the 4th power is just 1. 2 times 3 is 6, minus 1 is 5. 2 to the 5th is 32. And 6 factorial, well, this actually gets us right to here. So we have found this in sigma notation. We have the actual series that describes this. I know it's a little confusing. It takes just a little bit of logicking out and working our way backwards, but that's how I would approach it. I hope it's helpful.